Welcome back to the deep dive. Today we're tackling a topic that, I'll be honest with you, I completely misjudged when I first saw the title in our stack.
Oh, yeah.
We're looking at context engineering, and my knee-jerk reaction the second I saw those words was, okay, great.
Here we go again.
Here we go again. Another guide on how to write better prompts for ChatGPT. You know the drill, right? Add it, please. Tell it to act like a senior Python developer, or explain it to me like I'm 5. I thought we were doing a tutorial.
It's the classic assumption. It's almost a reflex at this point. You see the word context near anything AI related, and you immediately picture that little blinking cursor in a text window.
Right.
But what we're actually diving into today is significantly deeper and, honestly, much stranger.
Stranger is good. I like Stranger.
We're looking at a paper titled Context Engineering 2.0, The Context of Context Engineering.
Which is a very meta title.
Yeah, it's extremely meta. It's by researchers from SII and GAR, specifically Kishuo Hua, Luma Chanier, and their team. And their argument is fascinating because it completely reframes the timeline.
How so?
They're saying that what we think of as a new trick for chatbots is actually a scientific discipline with over 20 years of history.
20 years. Wait, that puts us back before the iPhone.
Before Twitter, yeah.
That's practically the Stone Age in tech years.
Exactly.
Oh.
It goes back to the roots of ubiquitous computing and human-computer interaction, or HCI. So the mission of this deep dive isn't just to learn how to talk to a bot to get a better recipe.
Okay.
It's to unpack how machines actually understand us,
Yeah.
or, more often, why they fail to. And according to this research, it all hinges on a concept called entropy reduction.
Okay, let's pause there immediately because entropy reduction sounds like we're about to do a physics problem. I barely passed high school physics. How does entropy apply to me typing on my laptop?
Well, it's the core problem of the communication gap between us and machines.
Yeah.
Think about carbon-based intelligence, you and me.
Yeah.
When we talk, I don't have to explain every single detail.
Yeah.
You fill in the gaps. You use shared knowledge, body language, all of that to lower the entropy or the chaos of the information.
Right. If we're sitting at a dinner table and I just say, pass the salt, I don't have to give you the GPS coordinates of the salt shaker or explain that salt means sodium chloride. You just get it.
Precisely. Humans are excellent at filling in gaps.
Yeah.
We are natural entropy reducers. We thrive on ambiguity. But silicon-based intelligence machines historically are terrible at this.
You just freeze.
They freeze. They see the chaos and they stop. So context engineering in the academic sense is all the effort required to compress our high-entropy human intent, our messy, vague desires, into a low-entropy representation the machine can actually execute.
This is the tax we pay for talking to machines. It's the translation layer between our messy brains and their rigid logic.
That is a great way to put it. It's a translation tax. And what makes this paper so great is that it maps the history of that tax across 4 distinct eras. We're going to travel from the 90s all the way to a speculative and honestly kind of wild superhuman future.
I love a good timeline. So let's rewind. Era 1.0. The paper dates this from the 1990s up to about 2020. They call this the era of primitive computation.
Or, as they also describe it, the era of the passive executor.
Passive executor sounds a bit harsh for the tech I grew up with. We're talking about the command line interface, early Windows, eventually smartphone apps. I mean, these were revolutionary at the time.
Oh, they were, but think about the role of the human in that relationship. In Era 1.0, the human acts as the translator. Because the machine had such a low tolerance for ambiguity, you had to do all the heavy lifting.
You had to translate your thoughts into clicks.
Into navigating nested folders or using really rigid syntax.
Oh, absolutely. I remember using early search engines. You couldn't just ask a natural question. You had to use Boolean operators and D, or not to, if you missed a quotation mark.
Syntax error.
Syntax error. I had zero ability to guess what you meant.
Exactly.
Yeah.
You were stripping away the entropy yourself because the machine couldn't handle it. You were doing the context engineering manually every single time.
Wow.
But this era wasn't a total wash. It gave us the foundational definition of context. The paper references a key definition by N.N.K. Day from 2001. He defined context as any information characterizing an entity relevant to an interaction.
So person, place, or object.
Right. And technologists back then built things like the Context Toolkit. They focused heavily on sensors, GPS, time, location. This was the golden age of if this, then that logic.
I remember setting those up. If I arrive at the office, silence my ringer. It felt like magic.
It did. But the researchers point out a critical limitation in Era 1.0 logic. These systems were context-aware, but only in a really triggered, rigid way. The phone knew where you were.
But not what I was doing.
Exactly. It didn't know what you were doing.
Right. I could be in the office, but maybe it's lunch and a ring is fine. Or I could be in a huge meeting where a ring is a disaster. The machine had the data, the location, but it completely missed the intent.
It missed the why. It just couldn't read the room.
Yeah.
It was aware, but it wasn't smart.
Hmm.
And that brings us to the seismic shift. The paper identifies 2020 as the turning point, Era 2.0.
The arrival of the large language models, GPT-3 and everything that followed. The paper calls this agent-centric intelligence.
And the vibe shift here is just it's
Hmm.
massive. We move from machines that demand low entropy to machines that can tolerate raw context.
That's a big difference, isn't it? Suddenly, I don't have to speak in code. I can dump a messy paragraph, a screenshot, maybe a rambling voice note where I stammer a bit.
And the machine just processes it. It figures it out.
It does the work.
It does the work. That is the key differentiator. It's performing that entropy reduction we talked about. But there's a nuance in the paper I think is really important here. We shifted from context-aware to context-cooperative.
Context cooperative. I like that term. It sounds nicer. But what does it actually look like in practice?
Okay, think about writing a report in an old version of Word, Era 1.0.
Mm-hmm.
It's a blank page. It just waits. It's passive.
Right.
Now think about Era 2.0. The system analyzes the paragraphs you've already written. It understands the tone, the argument. It might suggest the next section or point out a contradiction.
So it's not just holding the data, it's working with it. It's collaborating. It's saying, hey, based on what you said earlier, shouldn't we be talking about this now?
Exactly. And the data it's collecting has just exploded. We aren't just typing anymore. We're in the age of multimodal context.
Mm-hmm.
These systems are looking at gaze, where your eyes on the screen. They're analyzing voice tone.
Are you stressed? Are you being sarcastic?
Right. And connecting to IoT sensors in the room.
Which is amazing, but this leads me to the part of the paper that felt really gritty and honestly made me worry about my hardware. We're calling this the guts of Era 2.0 because my question is, if we are dumping all this raw data in, how do these agents not just crash or get totally confused?
And that is the central engineering challenge right now. You can't just feed an infinite stream of consciousness into a model. The context window is finite, and it's expensive to process. The paper outlines two main principles. First is the minimal sufficiency principle.
Which I assume is the fancy way of saying don't be a digital hoarder.
Essentially, only collect what is actually needed for the task.
Yeah.
Just because you can record my heart rate doesn't mean it's relevant to helping me debug Python code.
It just gets distracted by noise. It's like trying to do math while someone is shouting random numbers at you. Okay, and the second principle.
The semantic continuity principle. This is about maintaining the flow of meaning, not just data. If I switch from my laptop to my phone, the system should know the conversation is continuing, not just that the device ID changed.
Right. But how do they store all this? Because if I have a conversation that lasts for weeks, that's too much for the window. The paper talks about moving past simple timestamps.
Timestamps are really Era 1.0 thinking. Event A happened at 12.01. It tells you the order, but not the relationship. Era 2.0 moves towards sophisticated tagging marking context with roles like goal or action, or using hierarchical notes.
Hierarchical notes. Is that like a to-do list?
More like a tree structure. Instead of a flat list, the system organizes concepts. Project Alpha is the trunk. Marketing plan is a branch. Email draft is a leaf. It organizes by meaning.
That makes so much sense. It organizes information the way my brain tries to organize it. But the coolest concept in this section, by far, was self-baking.
Yes, I love this term, self-baking.
It sounds like a cooking show, but for data. What is self-baking?
Okay, think about how human memory works. You have episodic memory, the details of what happened today. I drank a latte at 8 a.m. I walked the dog at 8:30. But over time, you don't keep every single detail. You'd go crazy. Instead, you bake them into semantic knowledge.
Right. I don't remember every latte I've ever had. I just know the fact I am a coffee drinker.
Exactly. You compress thousands of episodes into a single fact. That is self-baking. The agent takes the raw, messy daily interactions and cooks them down into hard knowledge.
So instead of rereading a million chat logs to figure out who I am, it just accesses a baked fact file.
Correct. The paper talks about methods like periodic natural language summaries, where the AI literally writes a summary of your day for itself, or compressing context into vector embeddings.
Vector embeddings. We hear that term a lot. Can we stick a pin in that for a second? What is that in the context of memory?
In simple terms, it's turning meaning into math. Imagine a massive 3D map where words with similar meanings are physically close. Dog and puppy are neighbors, cat is down the street, carburetor is in another city. By turning your history into these coordinates, the AI can quickly search for relevant memories by looking for things that are mathematically close to your current question without reading every word you've ever written.
That is incredibly efficient. So if an agent doesn't bake, it's just stuck with this massive, unsearchable list of everything.
It's like having to reread your entire diary from age 5 every time you wanted to recall if you liked strawberries. It's computationally impossible.
Okay, and there's one other strategy they mentioned, subagents and isolation. This reminded me of how corporate hierarchies work, or should work.
It is very similar. The paper uses the example of a developer agent. So imagine you're building a complex piece of software. You have the main conversation about the high-level architecture, the vision. You don't want that cluttered with thousands of lines of error logs.
Right, that's context pollution. If the main brain sees all those errors, it might forget what we're even trying to do.
Exactly. So the system spins up a subagent. It has its own isolated context window. It takes this specific task, fix this bug, goes away, does the messy work, and then comes back to the main agent with just the result. Fixed it.
So the main context window, the main boss, stays clean and focused on the big picture.
Precisely. It mimics how a good manager delegates.
Okay, so that's where we are now, Era 2.0. We have agents, they cooperate, they bake memories, they delegate. But the paper says we are looking toward Era 3.0, human-level intelligence.
This is where we look at the immediate future. And Era 3.0 isn't just about processing more data. The paper emphasizes that the shift is about subtlety.
Subtlety, that's not a word I usually associate with computers.
It's the final frontier.
Mm-hmm.
We talked about multimodal inputs, but Era 3.0 takes that to the level of social context. Understanding silence, understanding eye contact, not just where you're looking, but the intent behind it.
So if I pause for a long time during a conversation with an Era 3.0 AI, it might understand that I'm hesitating, not just that the connection dropped.
Correct. It understands the negative space of communication. An Era 3.0 model might say, that was a difficult point. Do you want to rephrase? And it extends to sensory context. The paper speculates about digital smell or taste.
Whoa, okay. Digital smell. I'm going to push back on that. Why would my AI need to smell me? That sounds intrusive.
Well, let's move away from the chatbot interface for a second. Think about computers everywhere. Imagine a home assistant that can detect smoke chemically long before an optical alarm sees it. Or a system that can smell if a shipment of fruit is rotting.
Okay, that makes more sense. It's about giving the machine the same 5 senses we use to navigate the world.
Exactly. And intertwined with this is the concept of a true personal digital memory. And this is interesting. The paper argues that for this to work, it needs the ability to forget.
Forgetting is a feature, not a bug.
For humans, yes. If we remembered every pixel of every moment, we'd go insane. We prioritize, we filter. Era 3.0 systems will need human-like forgetting and recalling to stay relevant.
It's starting to sound less like a tool and more like a partner. But then we get to Era 4.0. And this is where the paper goes fully speculative. Superhuman intelligence.
This is the part that really captures the imagination.
The phrase they used gave me chills. The God's eye view.
It's a total reversal of roles. In Era 1.0, humans had to provide all the context. We told the machine everything. In Era 4.0, the machine constructs the context for the human.
What does that actually mean? How can the machine know my context better than I do? I'm the one living my life.
The paper uses a powerful analogy. Professional Go players. Remember AlphaGo?
Yeah, the AI that beat the world champion, Lee Sedol.
There was a specific moment, move 37, in Game 2. AlphaGo played a move no human would ever play. Commentators thought it was a mistake, a glitch.
Right.
But it wasn't. The AI saw a pattern of context on the board that human history and cognitive limits had blinded us to.
It saw a reality that was invisible to us because we were trapped in our own way of thinking.
Exactly. It had a God's eye view of the game. Now, apply that mechanism to your life. An Era 4.0 system has a view of your existence you physically cannot have. It sees your biological data, your work patterns, global economic trends, all at once.
So it creates what the paper calls proactive insight.
Yes. It initiates the interaction. Imagine a system that says, you need to change your career path, not because you said you were unhappy, but because based on your subtle stress markers over the last year and the trajectory of your industry, you are heading for a burnout in 18 months.
It uncovers needs I haven't even articulated to myself yet.
It redefined reality for you because it can see more of reality than you can. It's no longer just an assistant, it's an oracle.
That is both incredible and, I have to say, a little terrifying.
It fundamentally changes the definition of context. Context isn't just, where am I? It becomes, who am I? and where am I going?
So let's recap this journey. We started in Era 1.0, struggling to translate our thoughts into clicks and commands. We were servants of the interface.
Then Era 2.0, where we are right now. The machines are agents. They cooperate, they're learning to bake information and use subagents.
Moving toward Era 3.0, where they gain human-level nuance. They understand our silence, our environment. They become true peers with a memory that can also forget.
And finally, the speculative Era 4.0, the inversion, the superhuman system that understands us better than we understand ourselves, offering that God's eye view.
So what does this all mean for us, for the person listening who just wants to use their AI tools better?
I think the takeaway is that context engineering is really the history of human-machine communication. It's not just about coding or prompting. It's about bridging the gap between two very different types of intelligence.
Carbon and silicon.
Carbon and silicon. As the machines get better at reducing entropy, the burden on us lifts. We get to be more human, and the machine meets us where we are. We stop being translators and start being collaborators.
But I have to ask, that Era 4.0 vision, the machine telling me what I need before I know I need it, that raises a really big question for me.
It raises the most important question. If we reach a point where these machines possess a God's eye view and they begin constructing our context for us, defining our reality better than we can, are we ready for that? Are we ready for a world where the tool tells the user who they are?
If the machine optimizes your life based on context you can't even see, are you still the one living it?
Exactly.
That is a lot to chew on. From fixing prompts to defining reality, I don't think I'll look at a chatbot the same way again. That's it for this deep dive into context engineering. Thanks for listening, and we'll catch you on the next one.